Today, we're going to journey into a universe that's constantly expanding, but not with stars and galaxies, with ideas. We're diving deep into the huge, and let's be honest, often misunderstood, universe of mathematics.
So let me ask you this. What is math, really? I mean, for a lot of us, math class was just about solving for x, right? Or figuring out the area of a circle. But is that all there is to it? Well, the answer is a huge no. And the reality is way more exciting than you probably think.
So our first step here is to look beyond the numbers. We're going to peel back all those layers of classroom formulas and really get to what mathematics is at its core.
Okay, how about this for a better definition? Math is the science of patterns. It's all about finding these abstract structures and then proving with absolute rock-solid certainty truths about them using nothing but pure logic. You see, it's way less about calculating and way more about logical discovery.
You know, for the longest time, the definition was much, much simpler. Aristotle, for instance, he just called it the science of quantity. And that made total sense back then. I mean, it was a world all about counting your sheep and measuring your land. But as we're about to see, that simple definition just wasn't going to cut it.
So let's wind the clock way back to where it all began. For more than 2,000 years, the entire mathematical universe was really just made of two foundational and pretty separate worlds.
On one side, you had number theory. This stuff grew right out of the basic human need to count things and do arithmetic. And on the other side, you had geometry, which was born from really practical problems, like surveying a field or designing a building. For ages, these were the two ancient pillars of math.
But then the ancient Greeks came along, and with works like Euclid's Elements, they introduced something totally revolutionary. They basically said, hey, just seeing something isn't good enough. You have to prove it's true. You have to use rigorous, logical steps. And that idea, well, that became the bedrock of all modern mathematics.
So, how exactly does a proof work? It's actually a beautifully simple structure. You start with axioms. These are just statements we all agree are obviously true, like starting points. Then, you use super strict rules of logic to build an argument, step by step by step. And where you end up, that's a theorem. It's a statement that is now and forever proven to be true. Pretty cool, right?
Okay, let's fast forward a bit. The Renaissance wasn't just about incredible art. It kicked off a revolution in math by creating powerful new languages to describe a world that was constantly in motion.
First up was algebra. Suddenly, by using variables, letters like x and y, to stand in for unknown numbers, mathematicians weren't stuck with specifics anymore. They could create general formulas, which was a massive leap forward in abstract thinking.
And then came the big one, calculus. For the very first time, we had a tool to precisely describe and predict things in motion. We're talking everything from a falling apple to the orbit of a planet. This was the mathematics for a dynamic, changing universe.
And what's really amazing is that this game-changing tool wasn't just invented by one person. It was developed independently, at pretty much the same time, by two brilliant minds, Isaac Newton over in England and Gottfried Leibniz in Germany. It was clearly an idea whose time had come.
So for hundreds of years, the four big fields, arithmetic, geometry, algebra, and calculus, they reigned supreme. But then, right at the end of the 19th century, the entire foundation of mathematics started to shake.
Seriously, think about that for a second. What happens when the one field that's built on absolute certainty suddenly discovers its foundations might be broken? This was the great foundational crisis of mathematics.
The problems were coming from all over the place. Mathematicians discovered these bizarre new geometries where parallel lines could actually meet. They found head-spinning paradoxes when they tried to think about infinity. All of a sudden, the intuitive ideas that had worked perfectly for centuries just weren't rigorous enough anymore.
But here's the incredible twist. Instead of just collapsing, mathematics went through a kind of big bang. In the frantic effort to rebuild everything on a foundation of absolute rigor, using things like formal logic and set theory, mathematicians accidentally blew the doors of their universe wide open.
So just to really see the difference, think about it like this. Before this whole crisis, the mathematical world was pretty small. You basically had four main continents: arithmetic, geometry, algebra, and calculus. That was pretty much it.
and after, today there are over 60 distinct first-level fields of mathematics. We've got stuff like topology, the study of bendy, stretchy shapes, or game theory, the math of strategy, and so much more. The crisis didn't cause a collapse, it caused this unbelievable explosion of new ideas.
And this brings us to the final, and maybe the most profound part of our story. It's a deep mystery that sits right at the heart of math and its bizarre relationship with our reality.
The physicist Eugene Wigner put it perfectly. He called it the unreasonable effectiveness of mathematics. What he meant was, why? Why is it that these abstract logical ideas, often created by mathematicians just for fun, with no practical goal in mind, why do they turn out to be the perfect language for describing the physical universe? It's weird.
And this just shows it so clearly. The ancient Greeks studied ellipses just because they were interesting shapes. Almost 2,000 years later, Kepler figures out planets move in ellipses. Prime numbers were a pure curiosity for ages. Now they're the backbone of all our internet security. Non-Euclidean geometry was just a wild thought experiment until Einstein realized it was exactly what he needed to describe the fabric of space-time. It keeps happening. Which leaves us with one of the biggest, most mind-bending questions in all of science and philosophy. Are we humans inventing all this math like an artist creates a painting, or are we discovering it? Are we just uncovering a pre-existing blueprint of the universe itself? The debate still rages on, but one thing is for sure, that universe of mathematics, it's still expanding.
Discover review on India in just 7 minutes. Check out our quick and insightful video on Indian history, culture, and governance. A powerful overview packed into just 7 minutes and 2 seconds. Want more? Explore our All Videos playlist featuring a variety of informative, entertaining, and educational content designed to spark curiosity and fuel your YouTube journey. Whether you're here to learn or be inspired, our videos are crafted to be trendy, engaging, and optimized to thrive in the YouTube algorithm.